Hello, AP Chem students. When you really get down to the content of AP Chemistry, it really is all about understanding atoms and how they behave at different states of matter and at different temperatures. So in order to help you better understand the contents of this very difficult course, I believe that it is important for you to understand what an atom looks like at different levels. So let us begin with level 1, elementary particles. Now, there are a lot of elementary particles. However, the three ones you should concern yourself with are electrons with a negative charge, neutrons with no charge, and protons with a positive charge. Now, neutrons and protons are made of these things called quarks. And although they're not important to the AP Chemistry course, I believe that you should have at least a fundamental understanding. So neutrons have two down quarks and one up quark, which create a no charge, and then protons have two up quarks and a down quark in order to create its positive charge. And now electrons do not have any quarks. And so what's special about neutrons and protons with their quarks is that they come together to create atomic mass units, with each of them contributing one atomic mass unit to the atom. And atomic mass units is a very important conversion rate. However, electrons are 1,000 times smaller than a proton, so their effect on the atomic mass unit is practically negligible. Now let's see how these particles come together in order to create an atom. One of the most useful models for determining how these elementary particles come together is the Niels-Bohr's atomic model, which essentially shows neutrons and protons being centered around here, the nucleus, and then these electrons orbiting in different shells. So this is shell 1 and shell 2. Now there are very few important reasons why this is a very helpful model. First off, it shows how protons and neutrons are gathered together here. Basically, when you add neutrons, it creates this thing called an isotope, where basically it's the same element but with slightly different properties due to it being a little heavier. And in case you're wondering, adding more protons would change the element entirely. So here we have carbon with 6 protons and 6 neutrons. So it would have an AMU of 12. And we also see these 6 electrons. And going back to the shell idea, the very first shell it will always have 2. And the second shell, well, for carbon, at least neutral carbon, will have 4 electrons. And these are what are called valence electrons, because they're in the outermost shell and they partake in why these atoms bond with different atoms, where basically these atoms are either taken away from the atom or more electrons are added to the shell until it is complete. And so one more thing to take note of in this model is that there can also be another shell around here. And so then when, let's just say some energy in an electromagnetic radiation comes along and it hits, let's say, this electron, it can move up into this, it absorbs that energy, it moves up to here, but now the atom is no longer in its most stable state due to this electron being in a higher energy state. So it will move down and it will radiate back the energy that it absorbed in the exact same wavelength as when it absorbed it. Now, unfortunately, this model is a little misleading due to it being only 2D. And in fact, these shells are actually far more complicated. So let's take a deeper dive into that. So now we come to the modern day. And what I called shells before is actually called orbitals. And I did lie to you when I said they're called shell 1 and shell 2. They actually have their own designations. For example, what I called shell 1 is actually the 1s orbital. And it's essentially a sphere of probability. And what this probability represents is where the electrons of that energy level will be 90% of the time. And the other 10% of the time, they could be anywhere else, because electrons are very weird. They move around very, very sporadically, like a lot. So going to other levels, for example, we have the 2p orbitals, which I essentially called shell 2, and they have like this really weird ovalish shape. And yet again, this is where the electrons could be 90% of the time. And like as you go out more and more, the probability becomes less and less. But because there's so many of them, they could be quite literally anywhere. Um, but yeah, basically what will happen is that these orbitals will partake in the bonding. Like for example, let's say we have another atom here, this sphere. Essentially, what will happen was that these two will combine with these ones here, and they'll essentially share or take electrons as they need to create different types of bonds, which you'll learn throughout the AP chemistry course. And yeah, that's where we come to the modern day. Now, obviously, this is the most complex model and our most accurate. However, in my opinion, the Niels Bohr model is good enough. This is just what you're dealing with when you learn about atomic orbitals and its trend on the periodic table. Thank you so much for watching. Goodbye.